up code.org as well and go to current unit. Yes, and join, and let's go like that for a second and do that and that, and we can share and got it. No. Okie dokie. Go to calendar spreadsheet and you will see that there are some documents here that are linked for your convenience. They're available other places, but I put them here just to give you a good landing place or starting off point for the things that we're doing. So the project is not that hard. Okay. The hardest part, I would say, are two things. One is managing your time and actually like being productive rather than putting it off and doing other things. And the other one is attention to detail. We'll get to that in a second. So the project, this first document that is called task directions, I think, right here, feel free to open that up. And I put the length of it or the relative length because there's another document called course exam description that is much larger, and it's going to be more useful for the when you're studying for the test, but if you're taking the AP test, but just the task description is what we're working on now. So this project, for which everyone is going to do, if you're taking the AP test, you would then upload it to the College Board as part of your exam grade, but everyone is going to do it. Okay. The task is called the create task or the create performance task or the performance task create. You will see, or digital portfolio. These are all the same things. Okay. The reason why there is that is there used to be two performance tasks, the create task and the explore task, which the explore task was just a book report equivalent on something to do with tech. It was kind of a waste of time and they got rid of it. So there's just the create task, which was one of the performance tasks, which you will upload to your digital portfolio. It's all the same thing. Don't get confused. So the final project consists of 3 components. The final program code, which is just going to be a PDF of your program. Super easy, takes 10 minutes to make. I'll show you how to do it. There are tools to make it easy. A video screen capture of your app working. Okay, I think it's no longer than 30 seconds or no longer than a minute, and it has to be less than 50 megabytes. They don't want a super long explanation. Just show it working. That's it. And the written response, which they have a great template for that with very specific questions. The written response is essentially the only thing that's graded, except that the written responses, you need to copy in portions of your code. So you couldn't do them if you didn't also write the program. So it's all sort of the same thing. Just make sure that you upload all of the components to get the points. Otherwise you won't. Okay, so what are the requirements for the actual program? Okay, the program needs to have an input and an output, meaning the user has to do a thing, a click, a type, anything. Okay, an example of something that didn't have that would be the digital scene program that you did if you were in my class last semester, where the program just ran. You hit run and it did a thing. It may have done some really interesting things. It may have satisfied most of the requirements, but it doesn't have an input and output. Almost everything we did had an input and output. That's fine. Okay. You need to use at least one list that collects, stores, and manages data, manages complexity. You are allowed to use the code.org provided data sets and the get column thing, and those are lists. That isn't going to count for this component. You need to have your own original list that collects information as the program runs, changes as the program runs, manages complexity. Manages complexity just means the way lists work is it allows you to add things and remove things from lists, which makes it so much less complex than starting out a program declaring 50 variables. You can just have a list and you can loop through, do loops once to every item in a list. No matter if it changes, you can change the list. That's what it means by managed complexity. Okay, your app needs to have at least one function that contributes to the program's intended purpose. Okay, I don't know how you could do this without a function, but it's not looking for event handlers. Okay, you will have event handlers and you will have update screen probably, but that's not what they're looking for here. They want a function that uses at least one parameter. It doesn't necessarily have to be a return function, although that nails it. If you write a return function that has a certain level of complexity, receives a parameter, uses that parameter, and does some stuff and returns something that makes your program work, is called somewhere else, like actually has to be used. That's what you're looking for this. Now, you're going to have a lot of stuff in your full program, but the written responses are specifically asking for examples from your code that meet these requirements. So if you use as your example something that doesn't meet the requirements, even if you have something that doesn't meet the requirements somewhere else, you're not going to get the points. So a lot of choosing a good app is starting from the idea of what are the ways I could use a list? If you start with some great idea, like an idea for a game or something like that, that is super complex and fun and everything, if you aren't using a list to collect information and store information, it's not going to work. Okay. And once you have that idea for a list, what can you do to it? Okay. Obviously filtering, sorting, reducing, mapping, changing, all those things are great things to do with it. Okay. Somewhere you need to have an algorithm that uses sequencing, selection, and iteration. Iteration just means a loop. We've done that all the time. Selection just means a conditional. Sequencing just means things happen in an order, like one after another, which I don't know why they put that in there. I don't know how you couldn't have sequencing, but a great place to put your examples of a loop or a loop and conditional. Well, a great place to put your conditional is inside of a loop. And a great place to put both of those are in the example, your example of a function. Okay. That's going to get you the points, well, for the most part. Okay. You need to actually call the function. Like you can't just write a function and then not use it. And it needs to have to do with your purpose of your program, which again, I don't know how you could call a function and have it not contribute to the purpose. I don't know, like it doesn't actually do a thing. And there needs to be some sort of output. The screen needs to change. That's not that hard. Okay, then the components, the video, and the written response. You'll notice here that the program code is number 1, the video of your app working is number 2, and the written response is number 3, which is why in other places you'll see question 3A, question 3B, that just means it's about the written response. Okay, so if you see somewhere it says 3B gets points for this, well, where was question 1? Well, it's not question 1. It's written response is all 3. Okay, and this is where you're going to go through. This is literally what the digital portfolio template, website, whatever it looks like. You'll have these blanks and you're going to write this stuff out before, but you're going to copy and paste your text into their different short answer fields, and also your capturing of your code for very specific details and explanation. Okay, well, we'll get to scoring in a second. Actually, let's get to scoring now. Go ahead to, if you're following along on your computer, otherwise just look at one of the screens. Go to scoring guide. This is the key, literally and figuratively. The scoring is based on 6 rows, and each row is either 1 point or 0 points. You cannot get partial credit for a row. Okay. Just an aside, as I think of it, the way this is going to be graded in this class for your fourth quarter or most of your fourth quarter grade will be less rigorous than the way the AP College Board, can you put the food away, please? The way the AP College Board will grade it. They are strict about the grading procedure, or I should say more stringent. For us, each of these rows is going to probably be its own 10-point assignment. That way I can give you partial credit and not be as draconian as the College Board. But if you look at the descriptions of each row, each of the 6 rows, and put yourself in the mindset of a reader, the people who are grading, the row, which is either 0 or 1 point, has a list of do not award the point if the following is true, which is essentially just the inverse of what you have to do. But if you're grading, all you would need to do is look at the do not award a list if 1 or more is true, and try to look for reasons to not give the point. It sounds a little rough to say the reader's or the grader's goal is to look for reasons to not give you the point, but that's the most efficient way to grade things. Look for this, because as soon as you find something that falls into the category of not giving the point, you're done with that row. They got a 0 for that row. As opposed to looking through everything and checking to see if everything is there, you can look for reasons to not give it. Okay, but for your sake, you should be looking at both sides. And the rows you'll see are mostly based on the written response. Everything except row 1. Row 1 has a video that shows input, it working, and output, and has answers the first couple questions of the written response, which is like the purpose and things like that. The rest are based on only on the written response, which includes copy and pasting portions of your program code to the written response to talk about very specific things. All right, so let's look at some examples. Examples good and bad, which I think that the bad examples will teach you more than the good examples. Excuse me. So there are on this page, this link, which is actually just the current unit. The current unit is now create task. Okay, which that has the side effect of meaning that any work from lesson 5, unit 5 or unit 7, you need to come in at lunch to work on it. And also, as an aside, the due date for that stuff is going to be, let's call it end of day Tuesday. Okay, last day for late work. Okay, and yeah, I'll tidy that up shortly. And okay, so current unit is now create task, and that link for examples good and bad is just the student resources from lesson 1. And in this unit, you'll see there's only one bubble where you can do a thing, and it's this one right here. And when you get here, you will see that it's empty, completely empty, with all of the blocks that we've used and others are available for you to work on or work with, and all the design things and all the data that should look very familiar. But on lesson 1, the student resources just takes you to the same thing that I clicked on for examples, good and bad. Okay, first 2 documents here we just looked at, the task instructions and the grading rubric, good. Then there are annotated samples and video samples and written response samples. Okay, so sample 1, annotated sample, sample 1, video, and sample 1, written response. The annotated sample goes through the sample's written response, which looks like this. Eventually these pop in, I think. And explains why or why not they got points for that. Okay, in the annotated sample, this is where the student's response is, and in the regular example, or the actual written response is here also. Okay, but the annotated sample's a lot more useful, or a good place to start, because you can see what score this project got. This score got a 6 out of 6. That's good. Let's take a look at the video. You have seen this before. The word game helper. This meets all of the requirements, and equally as important, the written response explains how it meets the requirements to the direction it's required. Okay, yes, this uses the data set, the words data set, but that's not the point. The key is it's using the filtered list. Filtering solves a lot of the problems because you start out with a blank list, then you loop through the big list. There's a loop, and you have a conditional inside the loop. If something matches, okay, add it to the filter list. Bingo. There is a lot of the things. Okay, there's a little bit more in terms of specifics and making sure you refer to it in your written response, which we'll talk about shortly. Okay, yeah, so this one, sample 1, which is annotated, written, and video. Oh wait, video and written for 1 is fine, but it's a 6 out of 6. It's not going to tell you as much as annotated sample 3, video 3, and written response 3, which sample 3 got a 2 out of 6. Okay, they got a 2 out of 6. And they kind of got screwed over because if we'll go through in a second why they got 2 out of 6. But the app that code.org is using as an example is still good enough to get a 6 out of 6. Okay, it uses a list. Well, first of all, it has an input and an output. The user does a thing, something happens on the screen. It uses a list. Okay, this is a filtering list. And we looked at this before where you go through the list of dogs and you sort them or filter them by dogs of whatever size and then pick one at random. That's great. You have filter, you have loop, you have conditional, all that kind of stuff is great. But let's see why they didn't get the points. Okay, they got the points for row 1 and 5, but not the rest of them. Okay, row 1, they earn the point, displays a random, so the app does a thing. And there was a description in like the first written response thing. Okay, row 2. Okay, row 2 is about the list, shows how the list has been stored in the list. One that shows the data in the same list being used as fulfilling, identifies the name of the variable representing the list, describes what the data contained in the list does. The program code shows how the list is being created and processed in the 2 code segments. However, the name of the list is not identified. They lost an entire point out of 6 because they don't say the name of the list anywhere in the response. Explains what it does, explains how it sorts, how it's used, everything, but it doesn't say the name of the list is, and then whatever the name of the list is. They lost a whole point for that. Okay, row 4, was that? No, wait, row 3. Row 3 manages complexity. Okay, includes a program segment that shows the list being used to manage complexity, add things to a list, remove things, so on. Explains how the named selected list manages complexity. We explain it. Okay, you show the code segment and you explain it. They did not earn the point for this row. According to the decision rules, the student did not earn the point for this row because the written response did not name the selected list. This is pretty harsh for a minor mistake, but they lost 2 out of 6 of the rows. Okay, that's a third of the score because they didn't write the name of the list in their written response. The name of the list is on the code segment. Probably, I can't zoom in that far. Probably can. But they didn't say the name of the list is probably filtered dog names or filtered dog heights. Doesn't matter. They didn't say it, and they lost a third of the points because they didn't say it. Okay, a little harsh, but like I said before, attention to detail is one of the hardest parts of this. Okay, taking your time and making sure it goes through, or it does all the things. Okay, row 4, it lost the point. Okay, row 4 is about the your original function. Okay, it says student developed procedure. That means you can't use on events as your example. Of course, you'll need an on event because something's going to happen. But when you're giving your example of your function that meets the requirements, you can't use an on event. Okay, an event handler. And the code segment consisting of the procedure is not included in the written section. So you need to show the segment. And the written response describes what the, relating to the overall function. Okay, so they did not earn the point for row 4 because the procedure does not use any parameters. The procedure has to use, it has to receive a parameter and it needs to use it in the function. You can't just have it receive a parameter and then ignore it. Right? It needs to be used in the function. Okay, they got the point for row 5. They traverse a list. They have an if-else statement. That's great. Okay, sequence, selection, iteration. The function is good. Okay, and row 6 describes how the 2 selected procedure identified. Describe 2 calls. Okay, so your procedure, your main function, I forgot to tell this other class, needs to be called in 2 different locations. An easy way to do that is to have 2 buttons, like left and right, or up and down, or add, remove, that sort of thing. I don't want that to limit your ideas. Excuse me, limit your ideas. But either, oh, no. Having things that will send different parameters. We did this a lot recently where we had event handlers or on events that 3 of them called the same function. They each called the same function, but sending a different parameter each time. That's what they're looking for. They're looking for at least 2 calls of your example function, each time sending a different parameter. Okay, and if your function doesn't have a parameter, of course, you can't meet that requirement. Okay, so we've got examples. Let's take a look at the document called Survival Guide. So if you go to calendar spreadsheet, please bring up this document. I'll know you're paying attention because I'll be able to see it on your screen. It is called, assuming everything starts loading, it is called Survival Guide. Okay, these top 2 documents are code.org documents, and the other 2 are College Board documents, which code.org does a great job of aligning things with College Board things, but the official ones are the College Board things, which you'll notice here, the first however many examples are code.org examples, and the other ones are from College Board. They both are fine. The code.org ones don't have videos, but I suppose technically the College Board ones are more official. I don't know. Okay, so survival guide. Let's take a look. A lot of this we'll just flip through because we've already talked about it. Okay, about the task, the three things: your program code, a video of it running, and your written response. Okay, about this guide. In completing the course, you should already have the skills, make use of your time wisely, devise a program that will meet the task requirements. Okay. I've said this a lot before. Being inspired to make a project is great. It is great to have an interesting goal and really want this to work. It makes things easier to work on if you're inspired, but it's not requirement. Having a list is a requirement. Having a function that receives a parameter is a requirement. Focus on the requirements and work backwards, or try to fit everything in there. Okay, so in here we have activity highlight, tricky parts, organizers, recommended schedule, and checklist. Some of the stuff is on the other document, the planning assignment. I broke it up because one of them I want for points and the other one is just sort of a together thing. Okay, College Board resources, we've gone through there, and getting the create performance test mindset. We've done a lot of things all year to get you ready for it. You should be fine. Okay, requirements needs to be an input and output. Okay, we just went over this a few times, but just to reiterate, needs to be an input and output. User has to do a thing. You need to use a list that creates and uses lists, that creates and uses information. Okay, not just a static list of strings, like static as in it's there, whatever strings are in there are the only things that are used. You need some way to add things to a list and sort through them and possibly remove things. You need a function that includes a parameter, an if statement, and a loop. And you need to comment any code or use comments, the gray blocks with // to cite anything that you used, any images, any sounds, etc. It doesn't have to be, I'll double check, but I don't think it has to be, MLA or APA format. Just say this image is from that or what have you. Like I said, you have access to the data sets for your project, and that's a good place to start as long as your work is original. And you would need to cite that just somewhere, say that's where you got the information. But I would say instead of saying you got it from code.org, you could say you got it from code.org, but then say they got it from whatever the more information is. It will say where their information came from. Okay, source, the tape, what have you. Okay, where are we? Let's get rid of that and get rid of that and that. And is this planning guide? No, annotated. Sample, video, spring. There we go. Okay, cite your work. Okay, so quick activity. I'm not going to make you go through this, but we'll talk about the idea of earning the points for row 4 and 5. This is 4 and 5 are about your highlighted function. Like I said before, you can have a function that meets the requirements, but if it's not the one that you focus on in your written response, you're not going to get the point. They're not going to dig through all of your program code to see if you find an example, to see if they find an example that meets the requirements. Okay, so algorithm 1, function has a variable, uses a loop, doesn't use a conditional. Okay, row 4 is not an event handler, is a procedure, written response. They describe the procedure, we're guessing. Okay, this gets to the point for that, but for row 5, there is no conditional. There's no selected out selection in it, so it doesn't get the point. Algorithm 2, function has a parameter, score goes up by 1, has a conditional, but it doesn't have a loop, and it doesn't use the parameter in the function. It receives a parameter, but doesn't do anything with it. So that doesn't receive either. Okay, this one has a parameter, receives a parameter that's used. There's a loop, but there's no conditional. So it gets 4, but not 5. And this one, parameter that's used, a loop. Oh, that's not what I want to do. A loop and a conditional, both points. Super easy. And I'm not going to make you go through this one. Oh, yeah, it's a little tedious. Okay, so if you go to the app planning assignment, this is actually an assignment for points. Josh, he's not here. No, Yusuf, a thing. If you go to the app planning assignment, which is right here, it says 4 points. This is actually an assignment, 4 points. Go ahead and make a copy and put your name in it, in the title, top somewhere. And this is going to be collected via Canvas, upload Google Doc style. Okay, activity 1, narrowing it down. This, like I said before, is one of the big issues. Well, slightly different than the one I said before about being inspired but not meeting the requirements. 2 ways to mess this up: too simple or too complex. Too simple is obvious, you don't have the requirements. Too complex is spending too much time dealing with feature creep, which is a technical term, it is, for trying to add features to your app without focusing on the finish line. Okay? Making it too complex or having a too complex of a goal, but not actually hitting your mark or hitting the rows. Okay, so here we have some examples where you can write in ways to narrow it down and how that would use a list and what sort of standalone return function would need. Okay, idea for tic-tac-toe game: user creates an account. If they didn't have one, go to main game board. Player against a computer. Okay, need to program intermediate and advanced mode for the computer to play. And when the game is over, win totals updated, keep track of how long the game took. That is a very complex program. What are 2 or 3 ways to simplify it so the student can more effectively meet the finish line? And with that, how can they use a list, and what type of return function? It doesn't have to be a return function, but that is a great way to make it happen. Because the return function is going to receive parameters, and you can just do bullet point type of thing for this, phrases and whatnot. Okay, second example: volunteer at a health clinic. Make an app so the user can record information about what they eat, sleep, and exercise, blood pressure and weight. Based on the information provided, the app will provide recommendations to the user, how they can improve their health, diet, and exercise. Users can also personalize the look of the app with different colors. There's a lot of extra stuff in that one. How could they narrow it down to make the project more effective? And how could they use a list? And how could they use a function in this? Okay, and last one. Okay, an app about building, or an app for basketball stats. App to show a picture of the court. User taps on the court to indicate something happened there. We actually did this in one of our, one of the examples, and it was actually one of the more interesting and impressive sample apps, practice apps. But either way, they are presented with a quick menu options, shot, foul, steal, etc. And they select from a list of players that did it. And at the end of the game, displays the stat sheet for all the players and the stats for the game. Okay, that's a lot of stuff. How can they simplify it? What sort of information could they collect in a list? And what sort of function could they write that received parameters and did a thing for the project? Okay, once you're done with that, start thinking about ideas for your own. Okay, I want at least 2 different, majorly different ideas. How can you narrow it down to something that is achievable? Okay, what are your list opportunities? What sort of information can you collect, sort, filter, whatever? What sort of functions can you create that add to the function or the purpose of the app? And do you already have the skills to make this project? Okay, and do that for 2 examples, 2 brainstorm ideas. When you are done, you can then start playing around in the sandbox area, the lesson for Bubble 2, the only place you can work on things. And that's it. Oh, a quick side note. Games do not tend to work well. Okay, games are fun to write, but they tend to be very programming heavy and not use a lot of lists. Games aren't usually list centered. Productivity apps, which is the category of apps that aren't like fun, they like do a thing, tend to work better. Like to-do lists, you've got a built-in list. Something else that's collecting the user's options, like a Mad Lib, you know what Mad Libs are, type of app where the user is putting in words but it's hard to do well, at least you'd have a list there. I don't know what sort of how you'd implement a function into that other than update screen. But make sure when you're talking about function opportunities, it's a function that does something to make the app work, not just update screen. Okay, something that, because update screen isn't going to receive a parameter. I mean, I guess you could write it that way, but keep it simple and have your return function receive the parameter, maybe clear out a filtered list, run a loop, check something, and return the result. Okay. All right, that's it. Get to work. I'm happy to discuss opportunities